Okay, now for C12, June 2017, question number 6, International A-Level paper, IAL. Here we have a sketch for a triangular garden ABC. The garden has sides BA with length 10 meter. Okay, so let me just put that in there. You have BA, which is length 10 meter, and BC with length 6 meters, and CA all the way from there to there with length 12 meters. Okay, the point D lies on AC such that BD is the arc of a circle of center A of radius 10. Okay, a flowerbed Pcd is shown shaded in figure 2. Find the size of angle of BAC correct to 4 decimal places. So you're going to find this angle BAC. Okay, so let me just do that down here. Okay, so we're going to find the size of this angle here. We were told that this is 10 centimeters, and we're told that this is 6 centimeters, and we're told that all the way up to C was 12 centimeters. Okay, all the way up to C. So this is a classical case of using the cosine rule, actually. Okay, you have 3 sides of a triangle, and you need to find an angle. Now, I like to use a cosine rule in the form when I'm trying to find an angle as follows. So the cosine of the angle is equal to b squared plus c squared, where b and c are the 2 sides that make the angle, and then minus a squared, where a is the side opposite the angle we're trying to find. Okay, over 2bc. So don't always go by the markings. You know, it doesn't have to be that this is a and this is b and this is c. Go by the concept that the angle that you're trying to find, the side opposite it should be the one in this position in your formula. Okay, so now what we can do is we can say cosine A is equal to, so b squared plus c squared, it could be 10 and 12, it doesn't matter which way around, but A must be the 6. So 10 squared plus 12 squared over 6 minus 6 squared over 2 times 10 times 12. Now, we want to find the answer in radians to 4 decimal places. So what I need to do is I need to ensure that my calculator is in radian mode. Okay, so what I do is shift menu angle input to radians. Make sure it's in radian mode. Now, some of you have calculators where there's different ways to change the mode, but you should be very familiar with how to change the mode. So now let's put these values in. So we're going to have, I'm just going to put in one step, so inverse cosine of the fraction 10 squared plus 12 squared minus 6 squared over 2 times 10 times 12, and close that bracket, and that will give me the angle in radians. Okay, so I get 0.52314, and it continues 0.5221 22314, sorry about that, 22314, 5222314, continues. Now you want it to 4 decimal places, so we're going to stop right there. So it's going to be 0.5223. That's the angle A. Now what I'm going to do in my calculator, I'm going to store angle A under A, okay, in this memory. So if I need it again, it will be there inside my calculator. So that's part A done. Now part B says find the perimeter of the flowerbed in meters. So what we found is this angle is 0.5, let me just make sure, 0.5223. 0.5223 is this angle. This is 10 centimeters, 10 meters, sorry, not centimeters, 10 meters, It's a garden. Okay, so this is 10 meters, and this is 12 meters, and this is 6 meters. Okay, they said find the perimeter of the flowerbed BCD. Now that's the perimeter of the shaded section now. All right, so the perimeter of the shaded section is made up of the line BC. So the perimeter is equal to the line BC plus the line CD plus the arc from B to D. The arc from B to D. Okay, now BC, okay, is 6 centimeters. Now CD, now remember that this is from A to D is 10, and from A to C is 12. So this CD part must be 2. So you got the perimeter is equal to BC, which is 6, plus CD, which is 2, plus we need the length of the arc. Now the length of an arc is given by the radius times the angle if it's in radians, r theta. That's when the angle is in radians. So you got 10 times our answer 0.5223 whatever. Okay, so that is going to give us the perimeter of the flower bed, and we're going to give it in meters to 2 decimal places. So we're going to have here 0. I'll use this answer and I'll multiply that by 10. Oops. Which is 5.223 plus 6 plus 2, which is 8, plus 8, which gives you 13.223. 13.223, but we want the answer to 2 decimal places, so you should say that's 13.22 meters. That's the perimeter of the shape of the flower bed part. Okay, and now for part C, find the area of the flower bed BCD in meters squared to 2 decimal places. So you need to find the area of this shaded part here to 2 decimal places. Now the area of this shaded part is like the area of the whole triangle ABC minus the area of the sector ABD. If we take the area of the sector from the area of the triangle, we'll be left with the shaded area. So the area of a triangle, when you know 2 sides and the angle between them, so the area of a triangle is given by a half times AB times sine C. Okay, and the area of a sector, which looks like a pizza slice, is equal to a half times the radius squared times theta, which is an angle, okay, of the that's the subtended sector in radians. Okay, so those are the 2 formulas that we're going to use in order to solve this question. So I'll find the area of the triangle first, and then I'll find the area of the sector, and then I'll subtract them, and that should give us the answer that we require. So first of all, area of the triangle is a half times 10 times 12 times the sine of this angle between them. We don't use the 6 here. We always use the sides which make that angle, okay, that we know. And the side from A to C is what we need, not from A to D, because A to C is of the triangle. Okay, so we're going to do a half times 10 times 12 times sine of 0.5223. So we have the area equals a half times 10 times 12, this is the area of the triangle, times the sine of 0.5223, okay, as we had it in our calculator in radians. So now what we're going to do is we're going to say a half times 10 times 12, that's going to be 5 times, that's going to be 60, times the sine of, I've already stored it away, so we stored it under A. So 60 times the sine of A, which gives us 29.933, 29.933, ... So what I'm going to do is, in case we lose it, I'm going to store this under B. Okay, so now I have that value stored for the area of the triangle, and I'm going to find the area of the sector, which is like a pizza slice shape, and that's a half times the square of the radius. So a half times the square of the radius, and see the radius is 10. The radius of the sector is 10. Okay, so a half times 10 squared times the angle, which is 0.5223, as we had it stored. So that's 100 divided by 2, which is 50. 50 times 0.5223. So you have 50 times, and I've got it stored under A, 0.5223. So that gives me 26.1157, 26.115, and continue on. Now, so the required area, the shaded area, is going to be the difference between those two. So I'll take my answer from before, which I recall because I put it under B, minus my answer now, and that gives me 3.8175, 3.8175, which is to 2 decimal places is 3.82 meters squared. And there we have the answer to part C.